Welcome back to my channel. You're listening to Season 8. In this season, we'll dive into the big shifts shaping how we design, build, and run technology, and how these shifts connect to the way we think about business, services, and people. The world of IT and digital transformation is full of buzzwords: agile, DevOps, product-centricity, AI. But behind every term, there's a deeper story about where it came from, the problems it tried to solve, and what it really means in practice. This season is about more than just laying eggs. It's about cackling too, sharing experiences, learning from mistakes, and building collective knowledge. We'll explore the history of agile software development, the move from projects to true product thinking, and how to manage a backlog that actually delivers value. We'll talk about business model and value proposition canvases, what makes a strong business case, and why the shift from body leasing to a consulting mindset is so critical. There will be episodes on service excellence, DevOps culture, ITIL processes, service blueprints, and even the realities of running transactional systems like SAP. And of course, we'll look ahead at how AI and Gen AI are changing software development and requirements engineering. Some episodes will be short reflections. Others will go deep into frameworks and practices. And sometimes we'll bring in voices from the field who are living these challenges every day. So, wherever you are, commuting, working out, or just taking a break, welcome to Season 8 of my channel. Welcome to my channel. Today we're going on a journey to explore AI, not just as a futuristic concept, but as a very real part of our lives, with a special focus on the land of watches, chocolate, and innovation, Switzerland. Today we look at the history of agile software development. When people hear the word agile, they often think of sticky notes, stand-up meetings, and endless debates about frameworks. But agile did not just appear out of thin air. It has a long history shaped by military planning, engineering practices, industrial innovation, and the search for better ways to handle complexity. In this episode, we will explore how early approaches like waterfall and the V model emerged, how tailoring became important, how iterative and incremental thinking entered the scene, and how all this eventually led to the Agile Manifesto and modern frameworks like Scrum, Scrum of Scrums, and scaled Agile approaches. Along the way, we will connect these ideas to industrial phase-gated models, innovation practices, and even the Deming cycle and the Swiss 3K, command, control, and correct. The waterfall model has its roots in military and defense projects of the mid-20th century. These were large, complex, and high-risk endeavors, such as missile systems or aircraft programs, where rigorous documentation and strict control were essential. The waterfall model divided work into sequential phases: requirements, design, implementation, testing, and deployment. Each phase was completed before the next began, like water flowing down a series of steps. The idea was to reduce uncertainty by defining everything up front. For the military, this made sense. You could not afford surprises when building a nuclear submarine. But in software, where requirements evolve and change quickly, the waterfall model often led to rigid processes, late surprises, and projects that failed to deliver what users really needed. To address some of waterfall's shortcomings, the V model was introduced. Imagine the phases of waterfall bent into the shape of the letter V. On the left side, you have the definition of requirements and design. On the right side, you have testing and validation. At the bottom is the actual implementation. At the very top left of the V model sit the user requirements, which describe what the system should achieve from the perspective of the end user or customer. Moving down the left side, these are refined into system requirements that describe the overall system behavior, followed by architectural design, which defines the structure, and finally detailed design, which specifies components and modules. At the bottom of the V lies implementation, where the actual code or system components are built. The right-hand side climbs back upward. Each design step on the left has a corresponding test step on the right. Unit testing verifies the detailed design. Integration testing verifies the architectural design. System testing verifies the system requirements. And at the very top right, acceptance testing validates that the system meets the original user requirements. The distinction here is important. Verification happens at the lower levels. It asks, did we build the system correctly according to the documentation and specifications? Validation happens at the top level with users. It asks, did we build the right system that actually meets user needs? The military background of the V model shows clearly. It is rigorous, documentation heavy, and assumes stability. It works well when requirements are unlikely to change, less so in fast-moving business software. As projects became more varied, the V model was extended into what is called V model extended, or V model XT. This approach acknowledged that not every project had the same risk level or the same need for documentation. The key innovation was tailoring. Tailoring meant that the process could be adjusted depending on project type, risk profile, and complexity. A small internal tool might use a light version of the V model, while a critical medical system would use a full, rigorous version. Tailoring was an important step because it showed that one size does not fit all. It opened the door to more flexible thinking, and that flexibility eventually paved the way for Agile. Even while Waterfall and the V model were dominant, practitioners started experimenting with iterative and incremental methods. Instead of building everything at once, teams built small parts, tested them, and refined them in cycles. This approach was inspired partly by industrial practices like the Deming cycle, plan, do, check, act, which emphasize continuous improvement through feedback loops. It also echoed innovation models where prototypes are built, tested with users, and improved step by step. Incremental approaches revealed a big truth. Delivering value in small steps reduces risk and increases learning. This was the seed from which Agile methods later grew. The tipping point came in the year 2001 when a group of software practitioners met in Snowbird, Utah. They drafted what became known as the Agile Manifesto. The manifesto emphasized individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. This was a radical departure from the command and control mindset of Waterfall and the V model. It shifted the focus from predicting everything up front to embracing change and learning along the way. Among the earliest and most influential Agile frameworks was Scrum. Scrum organized work into short cycles called sprints, where a team delivered a potentially shippable product increment. It introduced roles like the product owner, who defined priorities, and the Scrum Master, who facilitated the process. It relied on ceremonies like daily stand-ups, sprint planning, and sprint reviews. Scrum gave teams a concrete way to live the Agile values. It was simple, flexible, and surprisingly powerful. Over time, larger organizations adapted Scrum to bigger contexts, leading to practices like Scrum of Scrums, where multiple teams coordinated through regular cross-team meetings. As Agile spread, the challenge became scaling it to large organizations. Frameworks like the Scaled Agile Framework, often called SAFe, emerged. These models attempted to balance agility with the need for coordination, budgeting, and governance at scale. Other scaling models, like Large-Scale Scrum or Nexus, also appeared. They all sought to answer the same question. How do you keep Agile principles alive when hundreds or even thousands of people are involved in building a complex product or service? While opinions vary on how well these frameworks preserve agility, they represent the ongoing tension between flexibility and control, between lightweight practices and enterprise-scale governance. Outside of software, many industries developed their own structured models. In automotive and medical technology, phase-gated models became standard. A project had to pass through gates with formal reviews at each step before moving forward. This gave management a sense of control and reduced risk. These phase-gated approaches mirrored the Swiss idea of the three Kesserns: command, control, and correct. Leaders commanded what needed to be done, controlled the progress, and corrected deviations. It was a mindset of authority and discipline, suitable for high-risk engineering. Agile, in contrast, emphasized empowerment, adaptation, and learning. Yet, interestingly, Agile still borrows from industrial improvement methods, like the Deming cycle, with its plan, do, check, and act rhythm. This shows that even modern Agile thinking stands on the shoulders of older management philosophies. Today, we trace the journey from military-born waterfall methods through the V model and its extensions into iterative and incremental practices, and finally into the world of Agile. We looked at the manifesto, Scrum, scaling frameworks, and how Agile connects back to industrial phase-gated models and the continuous improvement cycles of Deming and the Swiss 3K. In our next episode, we will focus on a very practical part of Agile and product development, managing the backlog. We will explore how to turn a backlog into more than just a list of tasks, how to prioritize effectively, and how stable product teams can use backlog management to organize their work and deliver real value. Stay tuned for episode 5 of my channel.